Hello, fourth graders! Mr. Guyton here from College Park, coming to you not quite live and direct, but from the beach. Yeah, this is kind of how things are going. No school at school, so we'll have school at the beach. Kind of sweet. So, before we get started, some of the things that you're going to need for today's lesson are a pencil with a good eraser, something to write on, like notebook paper or a spiral notebook, and then lastly, a group of post-it notes, something like this. Because every day we're going to write down a goal for what we want to accomplish. Today, my goal is, just for today, I will be on the lookout for similarities. That's right. But we can't have class at the beach all day, so let's get down to business. Okay, so we're talking about similarities. And more specifically, we're going to talk about the similarities with equivalent fractions. But before we do that, we have to understand the difference between two very important words. The first one is the same, and the second one is similar. You see, similar and the same are very similar words. Oh man, this is going to be tougher than I thought. If only I could think of an example. Only. I've got it. These two straws, they're just ordinary straws. They're both red. They're both the same size. They're both the same shape, same everything. These straws are, that's right, the same. Well, I've got these two dolphins here too. These guys are so cute. Look at those little guys. Same size, same shape, same everything. They are the same. But what happens when you have something that's mostly the same? Like these markers, for example. See, these markers are the same size, the same shape. They're even used for the same thing. But they're what we call similar because their colors are different. Sometimes I like to go down to the beach and I wear my glasses. But if the sun is really bad, I throw on a second pair. And if it's really, really bright out there, oh yeah, that's right, I throw on a third pair. See, these glasses are made by the same company. They're even the same style, but they're different colors. The lenses aren't the same. These glasses are similar. Now we're going to be talking about what we call equivalent fractions. And equivalent fractions are both the same and similar. They're also a little bit different. The cool thing is, though, even though they look different, they are exactly the same. Not sure what I'm talking about? Let's take a closer look. There are three different ways I want to show equivalent fractions. But before I can, I need to find my focus. And the best way to find your focus is to eliminate distractions. So you see I have it set up with 1, 2, and 3 examples. Well, let's just look at one for now. I'm going to pull out my trusty cover sheet to help me focus even more. Now what I want you to do is to draw 4 circles. And the first circle, we're going to cut it in half, right down the middle. If we shade in one of those, we've shaded in 1 out of 2 parts. For the second circle, I'm going to cut it in half again, but I'm going to double the number of pieces by cutting it in half again. Now I have 1, 2, 3, 4 total parts. If I shade in 1/4 and then 2/4, do you see how 2/4 is exactly the same thing as 1/2? Different name, same thing. Well, it doesn't just stop there. Let's go on to our third circle. And you guessed it, we're going to cut it in half, cut it into fourths, and then we can cut each one of those sections in half to give us 8ths. 4 times 2 is 8. There are 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So let's shade in half of those. 1, 2, 3, 4. 4/8 is equivalent to 2/4 or 1/2. They're exactly the same. And it doesn't stop there. Here's our last example. I'm going to cut it in half, cut it in fourths, cut it to eighths. And does anybody know what comes next? Let's try it. We'll cut this in half, cut this in half. We'll keep going here. We'll cut each one of these in half. Now, I could count these, but let's solve this mathematically. I'm going to look for a pattern here. I've got 2, 4, not 6, but 8. So what's going on here? Oh, I see. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 would give me 16 equal parts. If I want to shade in half of 16, I can also follow a pattern. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 sixteenths. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Let's try another example. This time I've drawn boxes. It doesn't just have to be pizza pies. We can do brownies too. But this time I'm going to separate my boxes into 3 equal parts. My total number goes on the bottom, as always, in the denominator. And if I shade in one of these sections, I've shaded in 1/3. Now remember, we're talking about equivalent fractions here. So if I do thirds again, but this time I cut those thirds in half, I now have 6 equal parts. And if I shade in 2 of those, 1, 2, I end up with 2/6. And if you look at our pictures, they're exactly the same. 1/3 is equivalent to 2/6. Let's do another example. What about this time if I cut it in thirds, and then I cut each one of those into thirds? You'll start to see that fractions and arrays are also exactly the same thing. I have 3 times 3, which gives me 9 in all. If I shade in 1, 2, 3/9, that's the same as saying 1/3. All right, last example. If I do the same thing where I'm separating my box into thirds, but this time I separate those into quarters or fourths, I'm left with an array that is 3 times 4. 3 times 4, as we all know, is 12. If I shade in 1, 2, 3, 4/12, I get the same thing as 1/3, 2/6, 3/9, 4/12. Let's see if there's a pattern here. If I double 1, I get 2. If I double 2, I get... No, that doesn't work. Oh, wait a minute. It's simpler than that. 1, 2, 3, 4 across the top. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And 4 times 3 is 12. There's almost always a pattern. All right. On to our number 3. It's important for us to understand that it's not just with filling in shapes that we can show our equivalent fractions, but also with sets. Here I have 1, 2, 3, 4 sets of 8 circles. If I want to do 1/2, another way to say that is 1 out of 2, or 1 out of every 2. So I can shade it like this. 1 out of 1, 2. 1 out of 1, 2. 1 out of 1, 2, and 1 out of 1, 2. We've got 1/2 are shaded in. That's the same as saying 4/8, am I right? Yeah. Let's move on to the next one. How about 2 out of every 4? 1, 2 out of 1, 2, 3, 4. 1, 2 out of 1, 2, 3, 4. It's 2 out of every 4. The same thing as 1/2. Let's keep going. Almost there. Home stretch. Let's try 4/8. 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8. Notice how they're all equivalent. They're exactly the same thing. Well, what happens if we want to do 16? And if we're going to do half of 16, we have to do 8/16. But we only have 8 circles here. Sounds like a challenge to me. Maybe if we were to cut them in half, and we, instead of saying each circle is worth 1, now each half is worth 1. So then we would have 2, 4, 6, 8 out of 16. Now, if that last one there is a little tricky for you, don't worry about it. But I will tell you this. When you're working on fractions, or anything in math for that matter, it's important for you to try it on your own. Watching someone do it is one thing, but trying it on your own is where you're going to make real discoveries. Well, that was fun. Hopefully you had a good time too. You know, all this talk about equivalent fractions is sort of making me sleepy. Good thing I got my blanket and my pillow. Only question now is, do I sleep for 30 minutes or just a half hour?